Okay, bachcho. So last few classes, we are seeing this chapter 4, moving charges and magnetic effect of current. है ना? So moving charges we are seeing. Can anyone message plot number 1? Oh my God, children are waiting outside. Plot number 1, room number 4. Plot 1, room 4. Hello, boys. Hello.
Yes, sir.
Yes,
Can
sir.
anyone message? Can anyone help me put in the group plot number 1, room number 4? Okay. On any building. Please message. Abid. Leave your chapel inside. Leave your chapel inside. अभिदन सर मैसेज कर दिया बेटा.
Sweet I'll message right now.
Did you message in the group? Oh boy. It's amazing. Are you getting my voice? After switch on the AC, please tell me. Hello. Are you getting my voice clearly?
Yes, sir.
Yes, sir.
So, bachcho, chapter 4. What are the things we have seen? Just in 2 minutes, I'll do the recalling so that you will remember. So that what is today I'm going to teach you, and today what answers we are going to see. All these things will be able to understand. The first thing is what you should know, bites of
सर आपका वॉइस क्लियर नहीं है.
I am not audible.
just stop the AC because they're not getting me. Switch off. Sorry, dear, okay. Huh? So the problem is they won't get my audio. That's why I'm not on the AC. You want my mic? Now are you getting my voice? Hello, hello.
Yes, sir.
Yes, sir.
So what is bad sortla beta? Bad sortla, you know that dB will be equal to mu1 by 4 I dm multi by R. This you should never forget. Okay, bachcho. So this is the Bayes sortla. And if I ask you vector form of Bayes sortla, immediately you should say that what is the vector form? dB
You
equal
not
to
by 4 5.
by dl cross R. This has a lot of meaning. dl cross R has a lot of meaning. So dl cross R cube. This is a vector form. And here when the dB is maximum, that also you should know for doing the numerical. So when the dB is maximum, dB is maximum when it is when dl cross R should be perpendicular. That is sine 90. Sine 90 is there. Sine 90 is there means sine 90 is 1. So sine 90 is 1, dB is maximum. Okay, so that you should remember. Sine 90 degree. And dB is minimum. That is 0. dB is almost 0. So dl cross R, that is sine 0 degree by. Sine 0 degree by dB is minimum. That is also you should know. And then we have seen that parts of for straight conductor, what is the magnetic field? For magnetic field for straight conductor. You not very well here. Even I might before I write, you should say online children. You not I
4
might
pi
You know 4
sine
by
sine 5 plus sine 5
by A sine I1 plus sine.
sine fed.
Okay. Magnetic field is infinite conductor. Infinite conductor.
mu naught I by 2 pi a.
2 by A. Sharanya is sleeping mode. Magnetic field due to infinite conductor. And then magnetic field due to coil. Magnetic field due to coil at the center.
You not by
You
2
not
pi.
Unit I by 2 pi r.
2R, very good. You not by 2R. Good. So all these things you know. And then magnetic field, if it is a semicircular coil, what will say? So mu naught I by
Semicircular call mu unit 2r into 1 by 2.
1 by very good, very good stuff. So magnetic field due to 3/4 of the coil. 3/4 of the
Mu
coil
naught I by 2a into 3 by 4.
very good. Mu naught I by 2R into
3 by 4.
then if it is quarter of the circle,
Mu
of the
naught
circle,
I by
2
2r
by
into
2
1
pi
by
r
4.
1 by 4.
mu naught I by 2R into 1 by 4. Very good, very good stuff. Fantastic. Now, after knowing this, after keeping this in mind, after keeping all the things in mind, we did some numericals also. Today, what we are going to learn means in girl section I finished, one in boy section I didn't finish. That I finished in 3 to 4 minutes. Okay. If you know that question, then we can do some of the numerical concept based on the question. So what is today's we are going to see means same magnetic field only. Question is same magnetic field, same circular coil, but not at the center, at the axial point. What is the axial point? So what would be the magnetic? So now take the topic and then we will do some numericals also based on this concept. So topic is magnetic field. Derive an expression for the magnetic field due to circular coil. Due to circular coil, magnetic field is circular axial. This is the final question. Final board question है. Axial point. Okay. So first we should know that circular coil. They are saying circular coil. So we take the circular coil. Okay. And then this axial point means x-axis. X-axis I am taking a point P. Take point P I am taking here. Center of the circle. So then from here to here, I'm keeping a distance x distance, and this imagine that radius of the coil is r, and then this I'm taking a small segment here. Okay, so this I'm taking a small segment dl here. From dl, the point P is at a distance smaller. Understand? So this is the diagram, and then because of this small segment, so we know that how we if you take any object, what Bayes law as per the concept of Bayes law, first we divide the object into small segments. Like that, I divided here a small segment dl. So for the small segment dl, the point is at a distance r. Don't look at the circle is like this. Okay, the circle will be like this. This is the y-axis, xy plane. This is the x-axis. If you take this as x-axis, and this will be a z-axis. Okay. So imagine the circle is not like this, then you will get confused. It will be like this. Okay. It will be like this. The circle is not like this, it will be like this. So that DL element is here. And DL and R, if you see that it is perpendicular. DL and R is perpendicular. Okay. But this R is not a perpendicular. This is an angle theta. This is not a perpendicular. So this is listen here.
Yes, sir.
This is the DL element, small DL element, and if I give the distance here, so this to this, if you see, always this is perpendicular. Wherever I see this is perpendicular. But this angle, if you see, it is reducing. It is reducing and it is increasing. Don't see this angle I'm talking. Okay. So there are two angles here. So DL cross capital R is theta and DL small r is 90 degree perpendicular. Okay. Now, if I take this smallest element dl, how the magnetic field line will act at the particular point P means the magnetic field line will exist in this direction. In this direction we take as a because of this smallest segment dl, and I'm getting a dB in this direction, small magnetic field. And as per the vector rule, if you divide this into two components, so you can divide this with imagine that the dB has elevated from the horizontal direction as theta. Theta angle to upar chala gaya. Imagine that. Then you know that how to resolve this into vector components. Can you tell me what is this line and what is this line? So first you tell me what is this line. If this is
dB
dB,
sin theta, dB cos
DB
theta.
there, sir.
Please wait. So first you tell me what is this line.
Cos theta.
No, say properly. If this is
dB
dB,
cos
what is this
theta.
line?
dB cos theta.
You should not say cos theta. I told you several times. I told you what is the magnitude in the hypotenuse that the resultant that you should see. First, you should see the what is the magnitude is given here. So what is the magnitude here? dB. So what is this line?
dB cos
dB
theta.
cos.
dB cos theta. That you should see. This is dB cos theta. And what is this line?
dB sin theta.
dB sin theta. dB. But this is about to have a diagram. Okay. See, Paramarian, who is some Paramarian is calling. I told you several times during the class hours, if you call, I cannot give. Several times I told you, but I can't. Maybe somebody is waiting. Oh my God. Hello, hello, hello.
Hello, sir.
Yes,
Are you
sir.
getting my voice?
Yes,
Yes,
sir.
sir.
Yes, sir.
हाँ बच्चों तो ये थोड़ा सबरिश मैंने गॉन है मोबाइल इज वेटिंग आउटसाइड नेम कार्ड कमी होता है लगा consider a circular card carrying we wish to calculate magnetic field at the point P. Let us get from the center. Let radius of the coil be capital. We know. I'm only writing we know. Every time I have to write we know, but we don't know actually. खाना पीना सोना काम करते हैं. So we know from Bayes law. Tell me the formula. Yes. Umer bolo. From Bayes law, Umer. Umer मैं जल्दी बोल. From Bayes law, dB vector will be equal to mu naught by 4 pi. जल्दी बोलो vector form.
Mu naught.
Good morning. Hello sir. Please come sir. Okay. dB equal to dB vector equal to mu naught by
सर
4 pi.
उमेर नहीं है क्लास में.
मैं नहीं क्लास पे. जाहिद बोलिए वेक्टर फॉर्म बोलिए mu naught by 4 pi. form. So we know from by dB vector equal to for the ideal of R cube. Okay. हो गया बच्चों? All the points हो गया? Hello, hello,
Extension.
hello.
Yes, sir.
Circle size, yeah, small element. Consider a circular coil carrying a current. Carrying a current time. We wish to calculate magnetic field and the time amount. हो गया? अब
एक
बताओ
मिनट।
over.
Yes, sir. Yes, sir.
For girls, no problem. Only for boys, I'm asking because girls already they did. I'm waiting for boys. Zahid, हो गया?
Done, sir.
Yes, sir. Okay, sir.
Okay. Now, bachon, listen. So we know from Bayes or Clark, dB equal to mu naught by 4 the ideal cross of RQ. Now, I told you, if you divide the complete circle into small segments, for this, because of this segment DL, I'm getting the magnetic field here. Suppose if I take the element here, suppose if I take the smallest element here, then from this smallest element that same distance are but in opposite side. So the dB here, the dB for this because of this small segment means the dB will act like this. You know, the dB for this element this will be the dB. For this element this will be the dB. So like you can see that for the entire circle we get two components. One is dB cos theta, another one is dB sin theta. So one component if you see for this circle, this is dB cos. For this smallest segment, this is dB cos theta, this is dB sin theta. Like that, for this smallest segment, if you take, again you will get the dB like this. So this will be the dB cos theta, and this will be the dB sin theta. So if you see for every segment of the dB sin theta vectors, if you see exactly it lies equal and opposite. Getting my point? So for this, every smallest segments, if you see dB sin theta everywhere at every point, dB sin theta will occur exactly equal and opposite. So they get cancelled each other. So we get only all the dB cos theta elements are added together. Then we calculate complete total. If you do the integration, you will be getting the final magnetic field. Okay. So this is the process. So you don't you just read like this. So for smallest element, this is dB cos theta. After writing this, now the magnetic field, due to small element dl, the magnetic field due to small element dl occurs as dB cos theta. Occurs as dB cos theta. हो गया? हो गया? Hello,
Yes, sir.
boys. Should I rub the board?
The last part छोड़ो sir वो formula वाला।
Now, in this equation, dB cos theta in this equation, what is dB? You substitute this dB here. And what is cos theta? Take the from the diagram cos theta, you substitute here. Then you will be getting magnetic field. Okay, for the smallest segment. So first you will from the diagram you will calculate what is cos theta. So write down here from the diagram. From the diagram. Cos theta. If you take this is theta, what is cos theta formula? Adjacent side
Adjacent
by
by hypotenuse.
very good. Cos theta equal to adjacent side by hypotenuse. So what is adjacent side? Capital R. This hypotenuse is Henabda.
Smaller.
Hypotenuse is this distance means then write R square plus X square. R square plus because this distance, hypotenuse distance means R square plus X square.
Sir, root R square plus X square.
Okay. Yes, yes, yes. हो गया?
हाँ सर.
Clear up the board?
Yes sir.
Okay, sir.
Now,
Yes, sir, you can.
substitute this term. Come to the magnetic field due to smallest element dl occurs as dB cos theta. So here two things are there. One is dB is here and cos theta is here. So dB का value यहाँ पे substitute करो and then cos theta का value यहाँ पे substitute करो. Therefore, substituting this in equation number 1. dB and cos theta to equation one equation of the magnetic field will be equal to dB का जगह डालो dl by r cancel कर दो v naught by 4 pi divided by r square. So in this r square also I can substitute that distance. Hence r square will be equal to r square plus x square. Okay, substitute this also here. Magnetic field will be equal to mu naught by dl v naught by 4 pi. So in place of r square, you substitute this r square plus x square and cos theta का value naught by r plus x square whole power half. Up to this, do you understand or not? Tell me.
Sir, what happened? Sir, what about DL cross R? So what about DL cross R? What did
DL or V naught by 4 पे हमें लगा V naught by 4 पे ideal ये R क्यूब को कैंसिल करता मैंने यहाँ पे R स्क्वायर रहेगा ना
Okay, sir, yes, sir, got it.
so what I'm doing V naught by 4 by I'm taking as it is ideal I'm taking as it is so R स्क्वायर का जगह मैंने क्या कर रहा हूँ this the distance is between R square plus X square now if you multiply this what you will get half plus 1
3 by
Yeah.
2.
very 3 by बोलना
No.
भाई
Yes, sir, mu naught by 4 by DL R by R square plus S square whole raised to 3 by 2.
3 by this magnetic field is for the hello? This magnetic field is for the smallest segment dl है ना this magnetic field is for the smallest segment dl for the entire circuit we have to acceleration है ना so for the entire circle the magnetic field anything if it is entire or full we know that integration so integral dB will be equal to mu naught constant को बाहर फेंक दो mu naught I by 4 pi और r और यहाँ पे क्या है r square plus x square whole power dl integral what is this integral dl tells you length of the circle what is the length of the circle
Circumference 2 by R.
circumference of the circle is 2 pi r so integral dB what's the answer integral dB
It becomes B.
magnetic field is so B vector will be equal to mu naught I r divided by 4 pi into r square plus x square whole power 3 by 2 into 2 pi because integral dl is L 0 to 2 pi r is 2 pi r substitute here shortcut मार दिया मैंने so B is equal to mu naught I r into r square divided by pi to pi cancel कर दो 2 into r square plus x square whole power 3 by 2 so this expression you have to memorize no other go बच्चों So magnetic field due to circular coil at an axial point. What is the answer we get? Means mu naught I r square 2 into r square plus x square whole power 3 by 2. This is the equation we get in the along the x-axis. I capital put. If you put here vector, I capital put. Okay. So ये है ना बेटा. Now only one
Yes, sir.
center. So this is a magnetic field due to axial point. Axial point the पूछा तो this expression you have to remember. Now already I told you. Already we did one question. Magnetic field due to circular coil at the center. What is the answer you get? Anyone apart from anyone apart from Abhid answer? Anyone? Magnetic field due to circular coil at the center. What is the answer we get? Mu naught? No, wrong. Magnetic field due to circular coil at the center point.
Mu naught I by
Mu naught I by?
sin. Mu naught I by 4 pi r sin.
Wrong. Magnetic field due to circular coil at the center. What is the answer? Mu naught I by 2r. Mu naught I by 2r. अरे अभी तो recall करें ना. Do you remember or not? Hello.
अच्छा sir. Mu naught I by 2 r.
Mu naught I by 2r. So already we did this. Mu naught I by 2r. So this is the magnetic field because of the circular coil at the center. Magnetic field because of the circular coil at an axial point is this answer. Or if you take the point piece outside, this is the answer. If you take the point piece inside at the center only, if you take the point, then this is the answer. Are you getting my point or not? All of you are getting my point or not? Jaldi boliye online.
Yes, sir.
Okay. In that case, now you see that the same answer we get from this equation also. From this equation also, we get the same answer. Now, how we get this answer, we will see. See that? Special case. Special case. If you take x equal to 0, मतलब बच्चों, Samita, if you take x equal to 0, if the distance axial point is ना, x is the axial point distance ना, so if x equal to 0, then magnetic field, what is the magnetic field? Tell me. If x equal to 0 means axial point is not there, na? So magnetic field at the center. Magnetic field x equal to 0. In place of x, you substitute 0. So mu naught I r square divided by 2 r square into 3 by 2 r cube.
R cube.
R cube r square cancel कर दो. So magnetic field at the center mu naught I divided by 2r. So same answer we get. Are you getting the point or not? So previously also I did this, and now also we get the same answer. Hello, online bachcho, are you able to
Yes,
understand
sir.
or not?
Yes.
sir.
After knowing this answer, now we are going to do numerical parts. Okay, both for boys and girls batch, please concentrate. So, can anyone take me the participant list? Can send me? Hello.
Sir, भेज दिया.
भेज दिया बेटा. 14 students are there. Okay. Zaid, Abhav, Abid, Adnan, or who's Adnan? Okay, Atufa, Chaidali, Mahi, Muhammad Arshad, Neha, Pooja, Rishi. Okay. Few of them are missing again. Sleeping. Friday, happily sleeping. So please remember this concept. Based on this concept, we are going to do some numerical. हो गया? हो गया?
Yes, sir.
हाँ सर.
Yes, बच्चों. Now try to answer this question. Wonderful question.
सर
Ah,
ये मैग्नेटिक फील्ड ड्यू टू सर्कुलर कॉइल ऑफ एक्सिस कितने मार्क का आता है डेरिवेशन?
5 mark derivation. 5 mark board question. 5 mark derivation आता है.
ओके ठीक है सर.
Do the numerical. 3 centimeter, 4 centimeter. This is 3 centimeter. This is 4 centimeter radius. 4 centimeter, 3 centimeter. From here to here, 4 centimeter. From here to here, 3 centimeter. This is the current. I1 is 1 ampere. Thank you. Loop 1, loop 2. Oh, hello. You know, this beautiful teacher.
Sit comfortably, man. Sit comfortably. Move behind.
Loop 1, loop 2. Image में क्या? Hello. Diagram is over. Hello, hello.
Yes,
Sir.
sir.
Yes, sir.
Tell you. Then what is the question they're asking? So, two coaxial loops are like this. They're placed like this in an axial axis x-axis. This is loop 1. This is loop 2. Okay. In this loop 1, what is given data? Radius is 3 centimeters given. For the bigger loop, radius is 4 centimeters given. From the center point O, this coil is placed at 4 centimeter distance, and this coil, circular coil, is placed at 3 centimeter distance. 3 centimeter distance. And in the first circular loop, I1 current is flowing, that is 1 ampere current is flowing. Okay. That means in this loop, how much current will flow? So I to there. So how to do this numerical? Find current I2 in loop 2. Can you guess? Can you give me a clue?
सर दोनों का हाइपोटेन्यूज वैल्यू सेम होगा सर.
What is the condition they say? Find the net magnetic field at the point. If the net, this is the condition to take up. It is given in the question. If the net magnetic field, if the net magnetic field at point O is 0. So this is the condition they have given. If the net magnetic field at the point O is 0. That means what they say, Bacho, when the magnetic field because of these two circular coil will be 0 at the center point means, what is the condition we should know means, the current should flow in opposite direction. When the current flow in opposite directions means, then the net magnetic field will be 0. That is the concept. So we know little bit. We know when current moves in opposite direction, then net magnetic field is 0 at center. Therefore, magnetic field due to loop 1 will be equal to magnetic field due to loop 2.
सर
देखो बेटा, आपको पता है अभी अभी हम एक डेरिवेशन कर रहे थे. मैग्नेटिक फील्ड ड्यू टू सर्कुलर कॉइल एट एन एक्सियल पॉइंट, है ना बेटा? मैग्नेटिक फील्ड ड्यू टू सर्कुलर कॉइल एट एन एक्सियल पॉइंट. व्हाट इज द फार्मूला बेटी? फार्मूला क्या है बोलिए?
I
IR
mu
square
not I
by
before mu not IR square.
Very good. फार्मूला we know magnetic field due to circular coil. We know magnetic field due to circular coil at axial point. Just now it is at axial point because they have given for both the circle axial point they have given. So axial point, what's the formula? B vector will be equal to mu naught I r square divided by 2 into r square plus x square whole power 3 by 2. This is the formula. Right? This formula you apply for both the magnetic field of the loop. So therefore, magnetic field due to loop 1 will be equal to magnetic field due to loop 2. So what's the magnetic field due to loop 1? We will apply the formula mu naught I. Current is 1 ampere. So first we write on I1. then r square, radius is 3 centimeter square, into 10 power minus 2 whole square, divided by 2 into r square into 10 power minus 2 whole square plus x square. What's x is 4 centimeters given, 4 into 10 power minus 2 whole square, whole power 3 by 2, whole power 3 by 2 will be equal to, for the second coil, now same formula I am substituting, mu naught. For the second loop, I2 current is flowing, I2, mu naught I2, r square, for this radius is 4 centimeter, 2 into 10 power minus 2 whole square, divided by 2 into r square plus x square whole power 3 by 2, 2 into r square 4 centimeter, 4 into 10 power minus 2 whole square, plus x square, distance is 3 centimeter is given, 3 into 10 power minus 2 whole square, whole power 3 by 2. So up to this, please copy. Okay? Just I'm substituting the formula. Sabresh, put it up. Yes, sir.
Sir,
Yes. Tell me.
सर वो 3 into 10 power minus 2 क्यों हो रहा है?
Who is that?
Yes.
Name please. Name please.
Sir Rishi.
Name please. Rishi.
Yes, sir.
ऋषि सेंटीमीटर को मीटर कन्वर्ट करने के लिए क्या करते हैं?
So सर हर बार मीटर में ही रहना है.
Then what? MK system ना?
Oh, okay sir.
Always
ठीक है.
try to give the answer in MK system ना, SA system. That is called SA system.
हाँ वो
समझ में आ
पता
रहा
है.
है? हाँ. हो गया? Any doubt? Up to this, any doubt?
No, sir.
Play up the board. Hello, hello,
Yes, sir.
hello.
Sir.
Hello.
No, sir. Yes, sir.
I1 is given. I1 is given in the circle. How much I1? 1 ampere. I1 is 1
1 ampere.
I1 is 1 ampere. So if you substitute 1 here, so see all the data are here, all the data here, we can cross multiply, means you will get I2 na. Very simple. See, very simple numerical. But while
Sir, is it I2 equal 0.5 ampere?
so that by seeing the diagram they get quivering. Oh, exam fear they develop. See, very simple numerical. So how what they have to do now? Listen. So mu naught cancel, mu naught cancel, and see here I2. I2. This also the same thing only there. Same thing. 2 into 3 10 power minus 2 also 3 plus 4 or 4 plus 3, whatever we have. This also same thing is there, na? So, and the whole bracket, this whole bracket also, this mu not can cancel. See how simple. I want 1 ampere. Therefore, we want I2.
0.56.
Very good. So, I2 will be equal to 3 into 10 power minus 2 whole square divided by, इसको नीचे ला लो, 4 into 10 power minus 2 whole square. Okay, बेटा? Now see here, I will be equal to 3 square is 9, 4 square is 16. 10 minus 2 whole square, 10 minus 2 whole square get cancelled. Getting my point? So 9 plus 16, how much?
Sir, 0.56.
0.5
6.
ampere. So this is your answer. Easy? It looks so big, but see, no certainty in that. Then, that's what the girl should not worry. Such a simple number will be there. Okay, बच्चों?
Sir.
Yes, sir.
Speed. Hello.
हाँ सर हो गया.
Yes, sir.
Neha Mahi.
हो गया सर.
Yes, sir.
बोलो ना यार, ये माही पटेल क्या कर रही है पता नहीं भाई.
सर हो
ब्रेकफास्ट
गया.
खा लेते हैं. सी मलयाली देखो क्या करे, मलयालम पुट्टू है ना, वो पुट्टू खा के बैठी है भाई साइलेंट से. हेलो.
हो गया सर.
हाँ, वेरी गुड, आई गेट द वॉइस. नो ओनली आई एम गेटिंग हर वॉइस. अतीफा क्या हुआ भाई?
सर
Chaitali, Chaitali,
हो गया सर
हो गया सर
Chaitali over.
हाँ हाँ
Zoha, hello, Zoha. Zoha still in sleeping mood, I think. Now, next question. This question you have to give the answer. Okay. All the girls, only girls, first girls. Here the one girl is sitting here. Samyukta, she will give the answer. Yes. Samyukta will give the answer. No, very simple question. Very simple question. You know already. I did this. Now the question is only I'm giving you the question, recalling only. So there is a question. Find the magnetic field at the center. The question is given like this. Okay. Center field. So find magnetic field center. Oh, the value is given. Find the magnetic field current loop. हाँ बेटा कुछ भी नहीं दिया है. Radius is R दिया है. Radius is R दिया है. Okay. Find the magnetic field at the center O. Yes. Shoot up the answer. You know I have very good Samyukta. Mashallah, mashallah. Very good. Samyukta did the answer. Rishid अभी आंसर सो रहा है भाई.
सर आपने तो बोला गर्ल्स आंसर करना
हाँ?
आपने तो बोला गर्ल्स ही आंसर करना इसलिए हम लोग चुप बैठे
Oh. See, Rishid nonsense. How he is. Sir, you told only girls has to answer. So what's the answer? Yes, Sharanya, what's the answer? Sharanya, what's the answer?
सर you
What's
not
the answer?
I you not plus 4
Huh?
I1
Oh, sorry, I didn't give the name. Huh? P Q R S T. Now, what's the net magnetic field at the center O? How to find out means there are how many conductors are there? One straight conductor is there, semicircular conductor is there, again straight conductor is there. So we have to write like this. Okay, step by step. Immediately you can give the answer. But for writing, you should write like this. First one. Conductor. Due to conductor PQ. dB, magnetic field. dB नहीं चाहिए, magnetic field. Magnetic field will be equal to 0. Due to conductor PQ, magnetic field due to conductor PQ at O. At O point A, the magnetic field is 0. Why it is 0? Because, why it is 0? Why
Because
it
it's
is
not
0?
directly connected to O.
Huh?
they're not
It is not
directly
connected to
connected
O.
to
Directly connected to O.
Yes, it's not
Connection.
joining.
What is connection? The wire का तार का connection देना है.
it's parallel
Very good, Sharnia. Nonsense fellows, monkey fellows, atom fellows. ये ऋषि क्या बोलते हैं?
perpendicular नहीं है ना
तार का connection देना है बोल के. अरे ऋषि fellows something यहाँ बराबर ही. सर तार में connection नहीं दिया सर.
सर वो तो आप ही थे सर
Wire का connection यहाँ रखा है. टाइम के wire का connection देना है. So this DL cross R. This is R radius. Here is also R radius. So everywhere if you see this is the distance. So DL and R is same direction. So DL cross R should be perpendicular, but here it is parallel. DL and R. DL and R are parallel. Parallel means sign 0. This is sign by itself subject other is sign 0. Understand? So sign 0 is 0. So magnetic field is 0.
0.
Same thing due to conductor ST at O. This is also same thing. Magnetic field is 0. Same as above. Answer. Third one, due to semicircular coil QRS. Now only we should write the formula. Magnetic field for the center of the circle. If it is the complete circle means you know that U naught I by 2R. So because it is half of the circle, what I told you, multiply with half. So the answer is U naught I by 4R is the answer. Please copy. Sorry, any doubt is there? Yeah, all the boys.
Done, sir.
Sir.
Mahi, Saidali, Zoha.
Done, sir.
Answer.
Hello, Atufa is there.
Yes, sir.
Okay. सोना नहीं बेटा. Okay. आधी नींद में है अतुफा. Are
नहीं,
you
sir.
sleeping also? नहीं. Very good. Now next question. Atufa will give the answer. Atufa and Zoha will give the answer for this question. Okay. My dear Atufa and Zoha, a question के लिए आंसर बनाइए. So I current, I current, I current, I current. I current or distance bend in the what will be the angle and direction of the field at the center. Y is the curvature. I is positive. Y. Okay. Yes. Find magnetic field at the center. O. Find net magnetic field at the center. O point. My dear Atufa, Zoha, जल्दी बोलिए. All the children, please keep answer ready. We'll check with Atufa and Zoha. Otherwise, all the children, please assemble for lunch Atufa house. Okay. Answer दे दी तो नहीं जाना है. Answer नहीं दे तो सब लोग lunch के we'll go to Atufa house. Okay. 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 Menu she will prepare whatever. No problem. We'll give chance here because if she gives the answer, no need. If she doesn't give the answer, we'll go to Atufa house. जल्दी बोलिए. फटाफट करो. 2 minutes take 2 minutes time. And take this as a straight conductor, infinite conductor. Name is given. Any name is given. No name is given. Infinite conductor. Consider this rod as an infinite conductor. जल्दी बोलिए बेटा. Yeah, perpendicular only. Yes. जल्दी बोलिए. हो गया. Atufa Zoha, if you are not saying, I'll change the children. जल्दी बोलिए. Not able to guess the answer. Shaida Limahi, Saranya.
So nu not I by 2 or brackets 1 by pi plus 1
Yes, Sharanya, tell
plus
me.
2.
Saranya, please. Tell me once again, please.
So nu not I by 2 r brackets में
Okay.
1 by pi plus 1.
How you did?
Sir, पहले वो B1 since it's the conductor is perpendicular, it will be infinite. So
Okay.
nu not I by 2 pi a. And the
Okay.
second one it's a full circle, so it's nu not I by 2r.
Fantastic
Oh,
girl.
net.
Fantastic girl. Very good girl. Therefore, beta, we are taking two objects are here. First object is the straight conductor, infinite conductor. Second object is the circle. है ना? First object is the infinite conductor. Anything you can take. First object you can take circle. That is not a big issue. So two objects are there. One is a circular object you are seeing. Another one is a straight conductor object you are seeing. है ना? They are asking you find the magnetic field at the center because of these two objects. So already you know the formula. That's why I'm telling you, remember the formula. Why? And behind this formula. Now you understand, madam? So you write on first. Very good. To Sharanya, we know magnetic field. We know. Several times I'm writing we know. Only I only know. और तुम पास दोहा देखो, आराम से देखो, पूरी वाला खा के आराम से सो रहे हैं। ये तुम पास दोहा है ना, we'll go and watch your house. So we know magnetic field due to circle. Magnetic field due to circle. What's the answer? So B vector will be equal to 2. Magnetic field due to circle and mu
Sir,
naught
mu naught I by 2R.
by 2R. Mu naught I by 2R. Then second, magnetic field due to infinite vector. Infinite vector. So it's B1 vector to B2 vector.
Mu naught I by 2 pi A.
2 pi
Is R.
2 pi r. Net magnetic field. Net magnetic field will be equal to B1 plus B2. B1 plus B2. So B vector will be equal to, दोनों को ऐड करना भाई, mu naught I by 2R plus mu naught I by 2 pi r. तो कॉमन बाहर निकालो, B vector will be equal to mu naught I by 2R, 1 plus 1 by 5. So this is your answer, final answer. Copy. हो गया?
Yes, sir.
Over.
Yes, sir.
Done, sir.
Girls, all the girls, very clear.
Yes.
Done,
Yes,
sir.
sir.
Clear up the board? Zahid?
Yes, sir.
Okay. Now do this numerical. The current is flowing. Okay. The distance of PQ. PQ का रेडियस दिया है ये, और PQ RS का रेडियस दिया है, B दिया है. Please copy the diagram. हो गया? तो ये diagram completely से the find the two circular segments. Two circular segments are shown and find the magnetic field at the center. Find the magnetic field at the center. इसका थोड़ा एक फार्मूला याद रखना है. And then remaining all the things you can do. हो गया बच्चों? Over.
Answer.
All the boys.
Sir.
All the boys.
Sir, can you
Sir,
read the question again? I can't understand your handwriting. Sir, can you like read the question because I can't understand your handwriting?
Yes, Neha. Don't worry, Neha. Neha, देखो बेटा. So there is a two circular segment. If you draw this, it will become a circle, है ना? Center point, है ना? देख बच्चों, if you extend this line, it will become a circle. It will form a circle, है ना? If you extend this line, it will form also a circle, है ना? है ना बेटा? Neha.
Yeah, yes.
That's what I have written. Two circular segments are shown, and find the magnetic field at the center because of these two circular segments. Okay. Now, this small segment, देखो बेटा, if you do this, if you extend this now, it will form as a circle. देखो, perfect circle बना, this is the center. But this is not required for us. That's what नहीं चाहिए हमको. They have given a small segment, but formula is different. That formula also you should know. Because which question they'll ask, we don't know. Okay. So a new formula we are going to learn from this. Now they have given a small segment. Circle में छोटा सा segment. In circle, a small part is called a segment. And here a big circle, a small segment they have given. This segment is at a distance of A. This segment is at a distance of B. That's what they have given. Two circular segments are shown as in the diagram. And find the magnetic field at the center. समझ में आया, boys and girls?
Yes, sir.
Yes, sir.
Now you tell me, my question to you is, you know this. I'm asking you. Forget about the segment. First you take this segment. PQ. I'm asking you, the current direction is in this direction. Huh? So can you tell me at O, in which direction the magnetic field will go? It is inside or outside. In these two options, you can select any one. At
Sir,
the point
inside.
O, because of this segment,
Or outside.
point
Wow.
O, magnetic field will come outside or magnetic field will go inside.
Sir,
Right.
inside.
Outside.
Very good. और एक दो ऑप्शन दिया तो वो भी बोलेंगे. Sir, outside, sir, inside,
Sir,
sir,
outside is there.
sideways, sir, downways, sir, upper ways, sir, 30 degree angle में जा रहा है, sir. How many times I taught this boys? Okay?
Sir, anti-clockwise direction. Sorry,
Tell me
clockwise.
clearly by using the rule.
Sir,
Answer is below.
anti-clockwise direction.
देखा और एक anti-clockwise direction. Who is that? What a scientists are sitting here. I gave you only two options, either out of the board or inside the board.
Sir, inside.
Inside the board.
Yes, sir,
How?
inside.
What rule you applied? What rule you
Sir,
applied?
right hand thumb rule.
Right
Yes, sir.
hand thumb rule. Only one boy is saying perfectly. So
Sir,
by
I
using
told,
right
sir.
hand thumb rule, now you tell me at the point O, because of this segment, magnetic field will come out or go inside.
Inside.
Inside rule.
अरे बोलो भाई, inside or outside?
Inside, sir.
Sir, inside.
Inside, sir.
How you are saying, Abhidan sir? Current is going in this direction. So current is going in this direction, and thumb is showing outside. So it will be outside. Now how you are saying inside? Abhidan sir, you said the rule is perfect, but nonsense giving the answer is wrong. Abhidan sir, I'm talking to you.
Yes, sir.
Arrow mark
Nashim
is in
hai,
this
sir,
direction.
wo.
Monkey, arrow is in this direction. Arrow.
Yes, sir.
बोल रहे यार. Hello.
Sir, नशे में है, sir, वो नशे में है.
अरे बोलो जल्दी बोलो. Arrow mark is in this direction. Yes or no?
Yes, sir.
So see this. This is the folding finger in this direction. Folding fingers in this direction. So you see my thumb. Thumb is seeing outside you. है ना? Getting my point or not? So
Yes, sir.
because of this segment, you get magnetic field line is outside. You get magnetic field line is outside. Very good. Now all the girls, please answer. Because of this segment, magnetic field will go inside or outside.
Inside.
Fantastic. See, the girls are saying this uniform answer. So see, the current is going in this direction. So folding finger in this direction. Now you see my thumb is inside. So it goes inside. That means at the point O, dot also is there, cross also is there. Now you tell me net magnetic field का direction मैंने कैसा लेना है? Net magnetic field का direction should I take? If you take this is B1, this is B2. अरे बच्चों tell me, is it B1 minus B2 or B2 minus B1?
Sir, B1 minus B2.
Fantastic boy. Why you said B1 minus B2?
Sir, because the distance is less. The magnetic
Because
field is
this
actually
distance is
inversely
less.
proportional.
Very good boy. Very good boy. This distance is less. So B1 will be magnetic field of B1 will be greater. Magnetic field of B2 will be lesser because of distance. है ना? Therefore, B1 minus B2. Fantastic. Fantastic. That's all. So if you know this, then you can do the numerical very easily. So first thing is you should know that as per the direction, we should create that equation. Therefore, net magnetic field at the center. Net magnetic field at the center due to two segments. Due to two segments, B vector will be equal to B1 minus B2. B1. Very good, beta. Now B1. What is the straight conductor का formula? मैं थोड़ा एक formula करूँगा. वो formula अभी तक you don't know. First now you understand. What is the straight conductor formula? Infrared conductor. Mu not I by.
Unit I by
straight
2 pi.
2 pi
No,
r.
straight conductor. Straight conductor.
Straight conductor.
Mu not I by 4 pi. भूल गया. Bias formula due to straight conductor. What's the formula? Forgot.
By 4 pi I
Mu
into
naught I by 4 pi into sin theta 1 plus sin theta 2.
Mu not I by 4 pi है ना? दिया ना याद है?
Yes, sir. Yes, sir.
Hello, hello.
Hello, sir.
याद है?
Yes, sir. That's mu naught I by 4 pi sin theta 1 plus sin theta 2.
I'll give you one more formula. Remember that. So mu not I by 4 pi a square into L. The new form, the new formula. Please note down this. I'll tell you what is here. First, you note down. L is length of the arc. L is length of the arc. 11th standard, you study the formula. Atifa is there? Atifa, check the participant list.
Yes, sir.
हाँ बोले बेटा एंगल का फार्मूला क्या है अतिफा 11th में पढ़े थीटा 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 का फार्मूला क्या है 11th में पढ़े ना
Theta equal L by R.
नहीं आतिफा को पूछ रहा मैं की आतिफा
जी सर.
बोलिए we know
वही मैडम.
theta is equal to arc by radius. This formula do you remember in 11th standard we studied theta equal to arc by radius. So if you take
Yes.
length of the arc is L, radius is A, so therefore here if you consider this as a theta, then theta equal to L by A. L equal to A theta. Therefore, L is equal to A theta. Okay? Okay? Okay?
Yes, sir.
Now you substitute here what is D1. Shall I rub this part? Shall I rub this part?
Yes, sir.
Yes,
All the
sir.
children do this part.
Yes, sir.
So B1. So you submit that after substituting this time in the formula, therefore B1 equal to mu naught I divided by 4 pi a square theta equal to L by A. No? I want L na L equal to A theta. Can I substitute A theta? So A theta. A get cancel na. B1 will be equal to mu naught I theta divided by okay. Okay.
Yes, sir.
In the same way, for B2 current, similarly B2 current, mu
mu naught I by 4 pi b theta, 4 pi b square by v square into b theta.
no need to put all these things. So just to take the common outside, mu naught I by mu naught I theta by 4 pi 1 by a minus 1 by a. So this is your final answer.
सर वहाँ पे उसको सॉल्व नहीं करना है 1 minus a and 1 minus b.
No need. If the value is given, you have to solve. Okay.
Okay, sir.
Radius दिया है तो then you have to do. Okay. Now, important question. It appeared in your board exam. जल्दी करो बेटा, जल्दी करके बोलिए. After finishing, please tell me.
Where is it?
Nothing.
Okay, time is 9:40. I have to go for prayer also. So inshallah, just I'll give you the question. You try to solve the question. In next class, I'll teach you the question. Okay. So first I'll give you the question. Please note on the question. It's a homework you do this. Because this is a board question. Board में आया था एक बार. Two coils each of radius r. Two coils each of radius r. Okay. This is P coil. This is Q coil. Two coils are perpendicular to each other. Perpendicular to each other. Having radius r and current I flowing I and 3I. Current I and sorry root 3I. Current I and root 3I. Is flowing in Q and Q. Find net magnetic field at open. So find magnetic field at. Please note out the question. So one coil is radius r, second coil is also radius r, but current is different. In one coil, P coil, I current is flowing. Q coil, root 3I is flowing. If so, what is the magnetic field at the center due to the two perpendicular coils? Okay, bachcho. So this is the question. Do it as a homework. Inshallah, we will see next class. Okay. Hello.
Yes, sir.
Yes, sir.
Okay,
Take
sir.
care. Take care. Allah Hafiz. Bye bye. Please send me the participant list. Beta. 15 students are attending. Please send me the participant list. Okay. Take care. Allah Hafiz. Bye bye.
Thank you, sir.
Okay.